So going ahead with the next topic of second unit, this is NFA with epsilon, and we are going to convert it to DFA directly. Now there is an intermediate method also which converts NFA with epsilon to NFA without epsilon, and then once you have the normal NFA, you can convert NFA to DFA using the method which we have already seen. But we will be looking at this method which is there in our syllabus. The indirect method, we do not have to study that. So now why is this NFA with epsilon? Because there can be epsilon transitions which exist in this given NFA. So now to convert this into DFA directly, what we'll do is the first step is to find out the epsilon closure of all these states. Okay, so let's see how to find the epsilon closure. So we'll find the epsilon closure of all these states. So we have S, next state is A, next state is B, and then C. So we will be finding the epsilon closure of all these states. Now how to find the epsilon closure? The closure includes the state itself. So this will include S itself, and then it includes all those states which are reachable using the epsilon transitions only. So from S, using the epsilon transition, I can move to A, then to B, then to C. So from S, using only epsilon transitions, I can reach to A, B and C. So I will have A, B, C here in the epsilon closure along with S. Now for A, the state itself is written. Next we will find all the states which are reachable from A using only epsilon transitions. So from A I reach to B using epsilon, and then I can reach to C. So B and C can be included here. Next is epsilon closure of B. So the state itself which is B, and from B following the epsilon transition we can reach to C. Epsilon closure of C. Now C, there is no outgoing epsilon transition, so we cannot reach at any other state following the epsilon transition. So only the state itself, these will be the epsilon closure values for all the states which are given in the NFA. Next step is to find out the or do the conversion of NFA with epsilon to DFA. So for doing this, okay, now we'll see at the different steps that need to be followed for this conversion. The first step here, it says to find the initial state of DFA, we have to consider the epsilon closure of initial state of the given NFA. So in the given NFA, the initial state was S. This is just the transition table for this same NFA, which need not be drawn. So epsilon closure. So what will be S dash? S dash is my initial state, which will be epsilon closure of the initial state of NFA, which is S. So epsilon closure of S we have already computed, it is SABC. So this will be my initial state of the DFA. Next we'll have to find the states and then perform the transition. So this is delta dash because this is the transition of DFA. So for any Q comma A, it is written as epsilon closure of transition of QA. Okay, so this is transition, which means you have to look at the given NFA table. Q dash lambda delta dash is what we are finding. Okay, so this is the initial state, right? So any processing needs to be started with the initial state. So the queue that we'll consider initially will be SABC.